Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 10, Checkpoint 3, Profiling the Bubble Sort C program before adding branch prediction. There are two main objectives of this video. First, to demonstrate and show you how to run the built-in profiling tool within Codasip Studio, and two, where to find the information to calibrate the performance of your core before you implement branch prediction. So let's move into Codasip Studio. Now, to extract all the information we would like through using the profiler tool built into Codasip Studio, we need to notify your CodAL or processor project to extract that information. So to do that, you need to be in the Explorer perspective, expand your demo project, and then there's this file called codal.config.conf. Now, if I open this up, under the simulator section, there is called enable profiler. You can see that it's enabled or not enabled. It says false. So I got to correct that and make that true. And now I also need to want to extract as much information as possible. So I'm going to set this to high. And we normally don't have the profiler enabled all the time because to extract all that information really slows down the simulations. And so unless we need the profiler, we will normally have that selected to be off so that our simulations are as fast as possible. Now I'm going to save my change. Now I'm going to switch over to the workflow perspective. And for my CodAL project, I'm going to regenerate the CA model. So this might take a little bit of time. And with the SDK CA model rebuilt, with the options of profiler enabled with high level of extraction of data, I now want to run my C program using the profiler. So I'm still in the workflow perspective. I'm going to go to my C program, bubble sort. And you can see that I have assigned my demo project to my bubble sort program. And it's already, you don't have to recompile because the extraction of information is through the simulation and not the compiling. Now I'm going to go to, instead of launch debug, I'm going to say profile. And when you click profile, all the different SDKs that are in your system will come up onto your screen. And I want to select my current project that I want to profile, which is my demo project CA model. And you can come down here, there's a tab called Task Profiler, and it's building. There's a few print statements in this program, and you can see it says sorting in process. And you can see right now all the numbers are being printed, and you can see that they are in order. And now I can tell that I'm finished. I've ran my profiler, but now I want to take a look at the data. If I go back up to this view of the bubble sort, you can see that under profile, I have now something called view profile. It's all my histories. If I expand that, you can see I only have one profile ran. The most recent profile will always be the one at the bottom. Since I only have one, it's right here at the top. But my most recent will always be at the bottom. I'm going to click on that, and it will pop up a window. And sometimes it's not as big as this one. But if I want to, there's this open in a new window. So I'm going to click on that. So you can see that it's going to open up a new tab in my browser. You will need to record at this stage the number of clock cycles that for your particular data set that you've been given in this assignment from your professor. And just let you know, my numbers are different because I'm using a different set of numbers than that have been provided to you. But you will need to record the number of clock cycles. The next thing you need to record for this checkpoint, go under resource coverage. Scroll to the bottom, and once again, all these clears are actually indications to clear the pipeline registers, which are basically making an instruction into a no-op. Now, you need to record two pieces of information down here. One, is the number of clears that actually are occurring in your design. So you can see that I have two sets of clears. So these are the number of no-ops that are being created. I have 406,000 in the ID stage and then another 406,000 in the execute stage. So I have actually a total of 812,000 clock or instructions that are actually being invalidated or no work. That is a lot of instructions. So that's the first thing to calculate is the number of no-ops being created through control hazards. Now, the second piece of information is how many control hazards do I have? Well, if you remember that for every jump that you're doing a clear of both the ID and the execute stage. So in reality, one control hazard is creating two clears or two no-ops. So in my example here, I'm actually creating 813,000 clears or no-op bubbles, but my number of control hazards is actually only 406,000. So you will need to record both of those for this checkpoint. Well, hopefully this video was helpful and good luck.